Hello everyone. We are given three second order systems and are asked to match their transfer functions with the nature of the system given below. To know more about the concepts used to solve this problem, kindly refer the NPTEL Control Engineering course Week 3 Lecture 3 by Professor Ramkrishna Pasumarthy of IIT Madras. The general form of a second order transfer function is given by g of s equals omega n square divided by s square plus 2 zeta omega ns plus omega n square, where omega n is the undamped natural frequency and zeta is the damping ratio. A system is said to be underdamped when the damping ratio zeta is less than 1, critically damped when zeta equals 1, and overdamped when zeta is greater than 1. In this question, we are given three systems, that is P 15 by s square plus 5s plus 15, Q 25 by s square plus 10s plus 25, and R, that is 35 by s square plus 18s plus 35. We are asked to find which of these system is overdamped, which means zeta is greater than 1, underdamped or zeta is less than 1, and critically damped or zeta equals 1. So the general form of a second order transfer function is g of s equals omega n square divided by s square plus 2 zeta omega ns plus omega n square. So we can find zeta and omega n from the above transfer function. So I'll just write down the characteristic equation of each of the system. So we have P, Q and R. So in system P, the characteristic equation is s square plus 5s plus 15. For system Q, it is s square plus 10s plus 25. And for system R, it is s square plus 18s plus 35. So if you compare this with the general form, we can immediately see that omega n square is 15. In this case, omega n square is 25, and in this it is 35. So omega n will be equal to root 15, and in this omega n is root 25, which is equal to 5, and in this case omega n is equal to root 35. So we have found omega n. Now let us find zeta. So by looking at the coefficient of the s term, you can write 2 zeta omega n equal to, we'll call it b. That is the coefficient of the s term. So zeta is b by 2 omega n. So in this case, the coefficient is 5. So zeta will be equal to 5 by 2 omega n, which is 2 root 15. And in this case, it will be 10 by 2 into 5. And here it is zeta equals 18 by 2 root 35. So if you compute this, you will get this is equal to 0.646, this is equal to 1, and this is equal to 1.521. So for system P, theta is 0.646, for system Q, theta is 1, and for system R, theta is 1.521. So this is less than 1, which means P is underdamped. This is equal to 1, which means the system is critically damped, and this is greater than 1, hence the system is overdamped. Looking back at the options, we find that the correct option is option C, that is system P is underdamped, system Q is critically damped, and system R is overdamped. Thank you.